Is first of all, let's clear one thing. Is my voice, is audio clear? Students, please confirm. Audio, video, screen, everything is visible now. Okay, very good, Logesh. Okay, so now, first of all, tell me how was your exam? Be honest in that how much you get in your exam. Very good, Tao Kannad. I think everything is clear now. So tell me your scores or how was the test? How you feel about the test? One thing is for sure, let's take a pen and paper and write down important things because we are not going to just solve the questions. We are going to learn few things so that if such type of questions come in exam, we will be able to solve them. Now, this is a question of Zener diode. And Zener diode also behaving as a voltage regulator. So whenever there is a voltage regulator thing used as a Zener diode or Zener diode used as a voltage regulator, there are certain things. And the same question always comes. What you should learn in that? One thing, or first important point. What is the first important point? That voltage across Zener diode remains constant after breakdown. Remember each and every point. So whenever diode is used as a voltage regulator, it is used in which condition? Breakdown, reverse bias condition, और उसमें भी कौन सी? A breakdown region. In breakdown, diode is used as a voltage regulator. One thing is clear. Now voltage remains constant. Another thing. And the question says that breakdown voltage of Zener diode is of 8 volts. Clear? That means the voltage across this Zener diode is 8 volt. Now can you see this Zener diode and this 1 kilo ohm resistor are in parallel? That means potential across this 1 kilo ohm resistor is also 8 volt. This is how the questions are solved in Zener diode. Always the same question come. Now, we have applied a potential of, you can say 15 volt here, out of which 8 volt is across the diode, then remaining 7 volt will be across this 0.5 ohm resistor. 15 volt is applied, 8 volt is across the Zener diode, then where is the remaining 7 volt? This 7 volt potential will be along this series resistor. This resistor is known as, or this resistor is known as series resistor. Now, again, now I will solve this question. You can see that if potential across this 1 kilo ohm, so for 1 kilo ohm resistor, we know the potential, we know the resistance, then I will be, and current in this resistor is given as IL. I is equals to, from Ohm's law, you can say that I is equals to V over R. That means V over R. V is what? 8. Resistance is what? 1 kilo ohm. Can you see that it will become 8 into 10 raised to the power minus 3 ampere? So current in the load resistor will be 8 milliampere. One thing is done. Now again you can write for which resistor they are talking about. For 0.5 kilo ohm, if I talk about, for 0.5 kilo ohm resistor, you know the potential. That means current in it is given as I is equals to, again V over R, potential is what? 7. Resistance is what? 0.5 into 10 raised to the power 3. Kilo means 10 raised to the power 3. It will become 14 milliampere. Now you know the current in this branch I, This current I is divided in two parts. One is IL, one is ID. From KCL, you can see that what you can see that I is equals to current entering the junction is equals to current leaving the junction ID plus IL. So ID will be I minus IL, that is 14 minus 8, that is 6 milliampere. So which option is correct? You need to pick the option. What are they are asking? I, ID and IL. I is 14, ID is 6, IL is 8. That is 1468. 1468. Option number B is correct. Is the question clear to you? The concept is clear to you. This is how Zener diode questions are solved. Moving further. Again, the question is the dimensions of R square C by L. R square C by L. One method is very simple in which you should write dimension of each and every term here. Another thing that is, I think that will be beneficial for you. They are saying that R square C by L. Clear? Out of this, just when you saw this relation, you remember a term time constant, that is RC. If you have studied LC oscillation and RL circuits, CR circuit, then there is a term RC. RC is known as time constant. So I am writing it in this way. RC, 1 R is still remaining divided by L. Clear? So RC is nothing but time constant. It has a dimension of time. R is resistance, has a unit ohm. L is inductance. Now, again, if I say, it will become RC into R. And again, if you know that, I'm doing it in a side. You know that XL is equals to omega L. L is equals to XL by omega. XL is nothing but ohm. That means resistance. Omega is nothing but second inverse. Second inverse means second. So unit of L is ohm second. Clear? Again, you can see RC has a dimension of time. R is nothing but ohm. I am writing the unit here only, ohm divided by ohm second. Ohm will cancel out. So it will become dimension of T divided by dimension of T. So it is a dimensionless quantity. Dimensionless quantity. Out of this, which option shows dimensionless quantity? It has a dimension of T. It has T minus 1. It has बहुत high dimension. This is dimensionless. So option D is correct. Clear? Moving further. This is Newton's laws of motion. Questions from Newton's laws of motion. Question says a body of mass 2 kg is lying on a rough inclined plane of inclination 30. So whenever you see inclined plane, just draw it. I have drawn the inclined plane of inclination 30 degree. What's next? The magnitude of force parallel to the inclined needed to make the block. Okay, let's just draw a block. This is a block of mass 2 kg, like this. Now, what are the forces that will be acting on it? One is its weight, that is 2g, mg, that is 2g. Another is normal reaction, that is n. Now, there will be a component of this normal reaction, that will be 2g cos theta, component of weight 2g cos theta, and another component is 2g sine theta. Now, what are they asking? They are saying the magnitude of force parallel to the inclined needed to make the block just move up the plane. That means they want us to calculate the force which is required to move this block in the upward direction. If block is moving in the upward direction, then the friction will be acting in the downward direction. So there will be a friction small f. Now you need to calculate this force F. Okay, just write out the equation in x and in y direction. So this is going to be our x and this is going to be our y. Yes, I am writing the equation. F minus 2g sine theta. Sine theta is nothing but 30 minus f is equals to 0. That means f is equals to 2g sine 30 plus f. Equation number 1. Now we need to calculate this frictional force. What is frictional force? We have learned that F is equals to mu into N. Mu is given as 0.3. Normal reaction is what? 2g cos theta. That is 2g cos 30. We can put the value 0.3 into 2g cos 30 is root 3 by 2. 2 and 2 will be cancelled. That is 0.3 g root 3. Now put the values. F is equals to sine 30 and 2 will cancel. That is g plus frictional force is nothing but 0.3 g root 3. Now put the value of g and you will get the answer. According to the options, you should put the value of g as 9.8 meter per second square. You will put the value. If you put the value, you will get the answer. No issue with that. I'm not going to calculate this value for you. You can put the value and solve it out. You will get the answer. One thing is very important to draw the FBD. Okay, so this is again a simple question from Carnot engine. Okay. This is a question from Thermody, and we have studied Thermody. So try to be responsive in this question. Question says there is a Carnot engine which takes 1,000 calories of heat from a reservoir at 827 degrees Celsius. Whenever you talk about any engine or any heat engine, it takes some heat from a source, performs some work like this we have represented. This is a source. This is our sink. It takes some heat Q1, rejects some heat Q2, and performs some work W. This is how heat engine we have represented heat engine. Clear? Now they are saying that Q1 is 1,000. They are saying that it has taken a heat of 1,000 calories from a source. This is source. And nothing else. Now listen to me. How much work is performed? Work done is asked. So whenever we talk about Carnot engine, work comes, we know that eta is equal to, or efficiency of Carnot engine is equal to output over input. Output is work done. Input is what we have taken is some heat Q1 as the input. So this is what work done is. Efficiency is work done over output over input. This is how efficiency is represented. Now we know the value of Q1. We want to calculate W. Only efficiency is needed. If we can get efficiency, we will get the result. Now, efficiency is calculated as the relation for efficiency is 1 minus T2 by T1. This is the golden relation of Carnot engine. T2 minus T1, T2 is the temperature of the sink, T1 is the temperature of the source. So it will become 1 minus T2 is what? Sink temperature is 27. If you talk about 27 degrees Celsius, and this T1 and T1 and T2 is mentioned in terms of Kelvin. So if I write T2, it will be 300 Kelvin. You know how to convert in Kelvin now? By adding 273. Divided by T1 will be 827. If I add 273, it will become 1100. So that will be 8 by 11. So now we know the eta. We know the efficiency. Put it in equation number 1. If I put this value in equation number 1, what we will get? Eta is 8 by 11 is equals to W by Q1 is 1000. So W will be 8 into 1000 by 11. Now you can divide. If I divide it, that will be 0.72. If I see the options, I am not going to divide it completely. I can sense the option is B. Because only one digit, after one digit or two digit, you can get that option going to be B, 727.28. Clear? Okay. Mohina, Rajesh, Ritu, Rishtiya. Are you getting what I'm telling here? Do you remember these relations or what? Moving further. Again, our question is from transformer. Okay, someone of you might be wondering that these questions are picked randomly actually. Why they are picked randomly? There are some questions which are of no use for the point of view of your exam. That's why I have not picked them. The questions which are really important for your exam or the type of question from which NEET questions are asked, I am picking only those questions so that this session will be beneficial for you. If you want, we will go with the pattern question number series of the question paper, but it will not be any help for you. So right now, what is it says? A transformer has 200 turns in primary. First of all, I will show you how transformer looks. There is a core, something like that. And there are few turns here, few turns here. Some AC input is given here and some load resistor is here. This is called primary. This is called secondary. Clear? So what it says in transformer, there are few relations that you should know. What is saying? Let's mention the data. This is primary number of turns in primary. NP is 200. Very good. Current 10 ampere. That means current in the primary side is given as 10 ampere. And the current in the primary side is generally denoted as input current. And that input current is 10 ampere. Okay. And input power is also given. Input power is given as P input is given as 2.5 kilowatt. Okay. Output voltage, they are saying that E out. Output voltage is what? 1000 volt. Find number of turns in secondary. Number of turns in secondary are asked. Now for that, we should remember few relations here. One golden relation for transformer is, that relation is E out over E in is equals to number of turns in secondary divided by number of turns in primary. This is the golden relation for transformer. Now, if you can see how many things are known to us. E out is known, NP is known, NS is to be calculated, and E in we don't know. If I want to calculate NS, or number of turns in secondary, what I should calculate first is the input voltage. Is the input voltage. So let's do it. We will solve it here. They have mentioned that input power is 2.5 kilowatt. That means power input is nothing but 2.5 into 10 raised to the power 3 watt. Input power is what? P is equals to VI. I think sometime in your life, at some stage in your life, you have heard the relation. Power is equals to V into I. So what you can write it, input power I am talking about, input voltage into input current is equals to 2.5 into 10 raised to the power 3. Input voltage we don't know, but input current I know is 10 ampere is equals to 2.5 into 10 raised to the power 3. So input voltage will become 250 volt. You can solve it, it will become 250 volt. Now put the value. E out is what? 1000. E input is what? 250 is equals to number of turns in secondary divided by number of turns in primary are 200. 0, 0. It will be 4. 200 into 4 is 800. So number of turns in secondary is what? 800. From the discussion, I think one thing is clear that you should remember the relations. You should remember the formulas here. Golden formula. Moving further. This is again a very important question on your screen. This question is from component of, or you can say, Earth's magnetism. Very important question. Question says the horizontal component of Earth's magnetic field at a place is this one. Okay. And the dip is tan inverse 3 by 4. Okay. Now listen. First of all, how many of you know what is dip, what is horizontal component, what is vertical component? If you know, or what is EMF induced, the motional EMF they are talking about. Do you know these things, or should I explain it a bit? Reply fast. Okay, I think you know that. Okay, so I'm not going to deal with it. Listen now. Make the question fit in your mind. What's happening here? Look at me. Look at me. Generally, Earth's magnetic field, the direction of Earth's magnetic field is from south to north. Let's suppose I'm sitting here and in front of me there is north direction and back side of me is south direction. So magnetic field is coming from south to north like in this way. Clear? One thing is clear. The direction of magnetic field is from south to north. Now again the angle of dip says that direction is south to north. This is clear. But it is inclined by this angle. By this angle means tan inverse 3 by 4. So it is inclined by this angle. Tan inverse 3 by 4. So actually the Earth's magnetic field, if you can see the pen here, if I remove the blur, okay, you can see that Earth's magnetic field is something tilted from the horizontal, like in downward something direction. This angle is known as angle of dip. If the Earth's magnetic field is tipped by some angle, then its horizontal component is known as horizontal component of Earth's magnetic field, and vertical this one. And they are saying that a rod is moving in the north-south direction, like rod is also moving in this direction and moving towards east. East means north, south, east, and west. So it is moving like this. So when a rod moves in a uniform field, some EMF is induced in it, and this EMF is known as motional EMF. And for that, which component of the field is responsible for this induced EMF will be the vertical component. Will be the vertical component. Now, listen. I am writing vertical component of field will be responsible for induced EMF. For induced EMF. Now, we are given with horizontal component, and there is a relation tan theta, or you can say tan alpha, is equals to vertical component divided by horizontal component. Tan alpha is nothing but 3 by 4 is equals to vertical component divided by horizontal component is given as 4 into 10 raised to the power minus 4. So vertical component will be 4 and 4 will be cancelled. 3 into 10 raised to the power minus 4 Tesla. This is vertical component of Earth's magnetic field that we have calculated. Now, what will be the value of induced EMF? The motional EMF induced in any rod or anything wire is B L V. This is the motional EMF. So B is what? Which component of magnetic field is to be used? Vertical component, that is BVLV. Put the values. Vertical component is 3 into 10 raised to the power minus 4. Length is what? 0.5 meter. Velocity is what? 10 centimeter per second. That is 10 into 10 raised to the power minus 2. If you solve this, you will get this one cancelled. 5 into 3, 15. Into 10 raised to the power minus 6 volt. That will be 15 microvolt. 15 microvolt. Clear? Okay. Move further. There is another question. What will be the equivalent resistance between A and D? Have you solved this, or should I explain this question to you as well? Answer me quickly. A and D for the circuit shown in figure. For that, okay, nobody is responding that what should I do? Is it okay? I will explain this question. Now they are saying every resistor is of 10 ohm. Connect A and D. About A and D, this is A and this is D. Whenever they are asking about few points, then connect those 2 points with a battery. Connect those 2 points with a battery. Now you can see that this 10 ohm resistor and this 10 ohm resistor are not the part of the circuit. Are not the part of the circuit. That's why what we can do, we can remove these 2 resistors. And how it will look like? it will look like something that. Out of this is 10, this is 10, 10, 10, and 10. That's what the circuit is. Now you can clearly see that these two resistors are in series. These two are in series, 10 and 10, 20, 10 and 10, 20. They are connected in parallel. Okay, can you see that? These 10 and 10 are in series 20, 10 and 10 are in series 20. They are also connected in parallel. So if you connect 20 and 20 in parallel, it will be 10 ohm. And after that, this 10 ohm, this 10 ohm, and this 10 ohm in series. So net result is 30 ohm. You will say, sir, this was very quick. You didn't write any step. That's how you should do. Because series parallel combination is a thing that you can do in mind for such kind of simple questions. What I am telling you, 10 and 10 series, that means 20. This 10 and 10 again series 20. Now they are in parallel. So 20, 20 in parallel, that means 10. Now out of these 1, 2, 3, 4 register, what we have put, it will something look like this: 10, 10, and 10, and there is a battery. 10, 10, 10. These 1, 2, 3, 4 resistors are replaced to 10 ohm. Now they are in series. They are in series, that means 30 ohm. Moving further. Okay, this is again not a difficult question, very simple question on your screen. The energy of ionization for hydrogen atom. Can you see this question is from atoms and nuclei chapter, or you can say atoms chapter of class 12. You have studied the same thing in chemistry as well. Now, if I explain few things, generally for hydrogen atom, some well-defined orbits are these. This is n equals to 1, n equals to 2, similarly 3, and if I move further, dot, 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 there is a infinity. For hydrogen atom, if I talk about the ground state energy is minus 13.6 electron volt. This is minus 3.4 electron volt, and similarly at infinity energy is 0 electron volt. This is how hydrogen, you can say, orbits of the hydrogen atom looks like, the energy of the hydrogen atoms. Now, what is the thing here? The ionization energy is what? The energy required to raise the electron from the ground state to the infinity state. From ground state to infinity, that means the energy required will be, they are saying energy of ionization EH for hydrogen atom will be 13.6 electron volt. From here to here, how much energy will be required? That is 13.6 electron volt. Now they are talking about for lithium atom. Generally, the energy in any state is given as general relation. I am telling you, this general relation is E is equals to minus 13.6 Z square by N square. So if I talk about for lithium plus plus, Z is what? 3. So energy in ground state will be minus 13.6 into 9. If I square Z square, that will be 9. So energy or ionization energy of lithium will be 13.6 into 9. 13.6 is nothing but EH. So that will be EH into 9. So which option is correct? What you should remember after this question, that ionization energy of any atom, or you can conclusion is this, the conclusion of the question is this: energy of ionization I denotes ionization is equals to energy of the ground state with mod sign. Mod sign means you don't have to put negative sign because generally energy in ground state is negative. So ionization energy is nothing but the energy in the ground state. For ground state of lithium, we have calculated the energy, and that energy will be the ionization energy. Simple. Moving further. Have you solved this question? Okay, so there are a lot of questions remaining. Um, Look at this question. This is the difficult question out of these. Most difficult and most conceptual question. Listen. Question says a point source of light is placed at the bottom of a water lake. Okay, so first of all, let's draw a water lake. Let's suppose this is the lake. This is the lake. And a point source of light is placed at its bottom. That means here a point source is placed. Okay, clear. Now again, if the circular illuminated area on the surface is equals to 4 times the square of depth of the lake, the refractive index of the water is. Now let's suppose refractive index of the lake of the water is mu. Now listen to me. This is a point source. That means light rays will come out of this in all directions. If this is a point source, light rays will come in all directions. And if light rays are coming in all directions, then one thing to be sure, can you see that light rays will go something like this? Few rays will go, this is not a straight line. You can sense that, you can get that, what I'm saying. Some rays will go like that, go like that. And can you see that when these rays come out of the water, they will bend something like that? Can you see this? And this is how it will look. Now there is a concept. The concept is that when rays are coming out from denser to rarer medium, there is a possibility of TIR. Possibility of TIR. TIR is, you know about TIR. Now I will draw it again in a beautiful way that will be beneficial for you. You understand what I'm saying? There is a possibility of TIR. Let's suppose this is a ray which is going straight. It will move straight, come out straight. And the ray which is inclined at some angle, let's suppose this one. So angle of incidence will be this one. And let's suppose if it is incident at an angle equal to critical angle. You know the term critical angle now? If it is incident at an angle equal to critical angle, that is theta c, then this will ray will not come out. However, it will graze the surface like this. And for any observer sitting outside the lake, he will not be able to see the image of the source, see the light of the source. He will not be able to see. Similar thing will happen in this direction as well. And rays will not come outside. And if you can see, I have shown you two rays, one on the right, one on the left. However, this thing will be happening in all over the lake. And there will be a circle in which light will be visible, and outside this light will not be visible. So this circle is known as circle of illuminance. This circle is known as circle of illuminance. Now moving further. Listen to me again. Okay. If this angle is theta c, by alternate interior angle, this will also be theta c. Let's suppose depth of the water lake is d and radius is r. Okay. So now, by the definition of critical angle, sine theta c is equals to rarer medium over denser medium. Rarer is 1, denser is what? Mu. We have assumed it to be mu. Sine theta c is equals to 1 by mu. Let it be equation number 1. But in the triangle, in this triangle, you can see that this is a triangle, right angle triangle. In this triangle, you can see sine theta c is equal to perpendicular over hypotenuse. Perpendicular is r divided by hypotenuse is under root. This hypotenuse will be under root r square plus d square. Equation number 2. The concept is important. Calculation part is not that much important, but the concept here is important. What is circle of illuminance? This is the most important question of ray optics. Now again, if you compare 1 and 2, you will get, comparing 1 and 2, r over under root r square plus d square is equals to 1 over mu. If I square it, I will get r square over r square plus d square is equals to 1 by mu square. Clear? What I need to calculate, the question again says, if you read it, circular illuminated area on the surface is equals to 4 times the square of the depth of the lake. That means, first of all, I need to calculate this area. Area of this circle is nothing but pi r square. That means I have to calculate pi r square. For that, I need to calculate radius. So now I'm calculating the radius. Listen here. If I cross multiply here, it will be mu square r square is equals to r square plus d square. So r square common if I take, it will be mu square minus 1 is equals to d square. So r square will be d square over mu square minus 1. This is what r square. Now again the question says, I have calculated the value of r square. Now a question says, on the next slide I will see, question says area is 4 times, area is 4 times square of the depth of the lake. Depth is d, that means 4 times of d square, this is given. Now area is what? Pi r square. Pi r square we have already calculated as d square over mu square minus 1. D square over mu square minus 1 is equals to 4d square. D square and d square will be cancelled. You can see that 4 mu square minus 1 is equals to pi. Clear? So mu square will be pi by 4. This 4 is taken here. This minus 1 will become plus 1. So mu square will be pi plus 4 divided by 4 under root. If you can see, check the options, mu is equals to under root pi plus 4. Pi plus 4 is option B divided by 2. If you take the under root, it will become mu is equals to pi by 4 under root divided by 2. So this is option number, I think, B. B is the correct answer. This is a good question of ray optics. I will take one more question of optics here. Okay, this is again an important question of optics. What it says, this is a question of wave optics, I think. A beam of light consisting of two wavelengths, 7,000 and 5600 angstrom, is used to obtain interference in YDSE. First of all, they are talking about YDSE. I will draw a simple diagram of YDSE. This is S1, S2, and this is your central maxima. Okay. The distance between slits is 1 mm and distance between screens, this is denoted by capital D. I think you know. This is denoted by small d. What is the least distance from central maxima where the bright due to both the wavelength coincides? This concept is again very important. Bright due to both wavelengths will coincide. First of all, mention few wavelengths as given data. Let's suppose lambda 1 is 7,000 angstrom and lambda 2 is 5,600 angstrom. Both the wavelengths are given. D and capital D is also given. Now, the maxima, we are talking about the maxima. For maxima, what we know that y is equal to, let's suppose this is the point of maxima. So y is equal to, this distance y is equal to n lambda d by d. Listen. This is n lambda d by d. Now again, if I say that for 7,000 angstrom, for 7,000 angstrom, lambda is more. And for 5,600 angstrom, lambda is less. That means the conclusion point is, or you can say the conclusion punchline is, if nth maxima of lambda 1 is at this point, then n plus 1th maxima of lambda 2 will be at the same point for the minimum separation. For the least distance, what will be the condition? That nth maxima of higher wavelength will coincide with the n plus 1th maxima of lower wavelength. So what I will write as y is equal to n for which wavelength? Lambda 1 d by d. And if I talk about wavelength 2, then what will be the equation? Y will be n plus 1 lambda 2 d by d. Listen to me, listen to me. The concept here. The concept is here whenever the question asks for the least separation between two maximas. Least separation between the maximas. Then what it should be? For nth maxima of higher wavelength will coincide with the n plus 1th maxima of the lower wavelength. Now they are coinciding. That means y is same in both the equations. You can compare them. So it will become n lambda 1 d by d is equals to n plus 1 lambda 2 d by d. Few things will be cancelled here. D by d will be cancelled. So n and lambda 1 is what? 7,000 is equals to n plus 1 into 5,600. If you solve it, 0 will be cancelled out. It will be divided by 14, I think. So it will be 5n is equals to 4n plus 1. That means n is equals to 4. N is equals to 4. Put this value of n in any of these two equations. Put this value of n in any of these two equations, you will get your answer. This is your part. Do it by yourself. Put this value of n in either of the two equations and you will get the value of y. Clear? How many of you remember this relation? This relation n lambda d by t. But remember one thing, this is to be remembered. This is the most famous question of wave optics. Then when the two maximas will coincide, nth maxima and n plus 1th maxima. Nth maxima of higher wavelength, n plus 1th maxima of lower wavelength will coincide. Now there are a lot of questions. This is a simple question. Again, this is simple question. Simple, simple. There are a lot of questions here, no? Okay. Actually, time is up, so we are not going to do it further. Let's end the session and try to remember the values that I have told you. I'm ending the session now. Bye, Acha. Bye, everyone.